Exams Vidhai is a non-profit initiative by the students of IIITDM Kancheepuram to give free coaching and resources to students preparing for national level competitive exams like NTSE and NMMS. In this video, let's discuss about the chapter Chemical Equations, and this is the second part in this chapter. In the previous video, we have discussed about how to balance a chemical equation and we've practiced a few questions. In this video, let's discuss about what is chemical reaction and the types of chemical reaction, and we'll also practice a few questions. Chemical reaction, a process that involves rearrangement of the molecular or ionic structure of a substance as distinct from change in a physical form or a nuclear reaction. In the previous video, the prominent example was Mg plus O2 gives MgO. Here, after balancing, we knew this should be the complete balance equation, and this is in solid form, and this is in gaseous state, and this is also in solid state. In this reaction, we can see oxygen has changed from its gaseous state to solid state. Therefore, there is a change in its physical state. This shows that this is a chemical reaction. What are the different types of chemical reaction? The different types are combination reaction, decomposition reaction, displacement reaction, double displacement, and precipitation reaction. Let's discuss about each and every reaction in detail. Combination reaction. As the word says, combine. We know 1 plus 2 is equal to 3. Here 1 and 2 combines to produce 3. Therefore, this is also an example of combination. Therefore, if two or more reactants combine to form a single product, it is known as combination reaction. And the example is calcium oxide reacts vigorously with water to produce slake lime, releasing a large amount of heat. This calcium oxide is called as quicklime, and calcium hydroxide is called as slake lime. In this reaction, calcium oxide and water combine to form a single product. Therefore, two reactants combine to form a single product. This is known as combination reaction. Such a reaction in which a single product is formed from two or more reactants is called as combination reaction. Solution of slake lime is used for whitewashing walls. What is slake lime? That is calcium hydroxide. Calcium hydroxide reacts slowly with carbon dioxide and air to form a thin layer of calcium carbonate. This is that reaction. Calcium hydroxide reacts with carbon dioxide to form calcium carbonate. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives it a shiny finish. It is interesting to note that the formula of marble is calcium carbonate. And another example of combination reaction is burning of coal. Coal is carbon. Carbon on reacting with oxygen produces CO2. Two reactants combine to form a single product. Therefore, this is combination reaction. And H2 reacts with O2 to produce water. This is also a combination reaction. What is exothermic reaction? If any reaction releases heat, it is called as exothermic reaction. Exothermic, thermic, release. Exo means send out. Therefore, exothermic. A reaction in which heat is released along with the formation of products are called as exothermic reaction. An example is burning of natural gas. Natural gas, this is called as methane, reacts with O2 to produce carbon dioxide and water. Do you know respiration is also an exothermic reaction. In this reaction, we take food in and that is broken down to produce energy along with heat. So, glucose on reacting with oxygen produces CO2 plus H2O and energy. So, in this reaction, the example which we took in combination reaction, heat is produced. Therefore, this is also an example of exothermic reaction. Decomposition reaction. Earlier, we saw that combination means two or more reactants should combine to produce a product. What is decomposition? Something should break down to produce many other products. Therefore, if one reactant breaks down to produce many other smaller products, that is called as decomposition reaction. In this reaction, we have ferrous sulfate reacting to produce ferric oxide. In this reaction, FeSO4 breaks down to produce ferric oxide, SO2 and SO3.
It is written as Fe2, but in the brackets it is given as ferric instead of ferrous. Why is it so?
Here we know that Fe3 plus and oxygen will have a formula of O2 minus. Therefore, when they combine, we get Fe2O3. This is why it is called as ferric. Here, iron has 3 plus. Therefore, it is ferric. In this reaction, we can see that a single reactant breaks down to produce simpler products. Here, we might be wondering, like, how is this ferrous sulfate breaking down? Naturally, ferrous sulfate will contain water along with it. So, it will exist as FeSO4 7H2O. This will break down to give out these water molecules, and this reaction is known as the decomposition reaction, and during this reaction it changes from green color to yellow color. Like it is very pale yellow, we can also say it is like white in color. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called as quicklime and calcium hydroxide is called as slakelime. We just discussed in the last line. Is used in the calcium oxide is used in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called as thermal decomposition. As the term says, thermal, that means heat is involved. Thermal decomposition means if it takes place in the presence of heat, it is called as thermal decomposition. Therefore, CaCO3 in the presence of heat, a thermal decomposition produces calcium oxide and carbon dioxide. Calcium oxide is quicklime and calcium carbonate is limestone. Heating of lead nitrate and emission of nitrogen dioxide. These fumes are nitrogen dioxide. Like if we are heating lead nitrate, we get a brown color fume, and that fume is nitrogen dioxide and it is very pungent. Therefore, PbNO3 taken twice on heating produces PbO2 plus 4NO2 plus O2, and this is nitrogen dioxide. Displacement reaction. If we are taking a solution of copper sulfate and we are putting a iron nail into it, that iron nail will become brown in color and the copper sulfate solution, which is naturally blue in color, will become colorless. Why is this happening? We are seeing a color change in copper sulfate also, and we are seeing a color change in the iron nail also. Therefore, there's something happening where both the reactants are getting changed, and this reaction is called as displacement reaction. What is displacement reaction? In this reaction, iron will replace copper sulfate from its solution and it will become iron sulfate and copper will be given out, because of which copper will be settled in the iron nail so that it is getting a reddish brown color. So this reaction, Fe on reacting with copper sulfate produces FeSO4 plus Cu. Therefore, iron is replacing copper sulfate. In this reaction, iron is displaced or removed another element copper from its reaction. This is known as displacement reaction. If we are taking another example, zinc displaces copper from copper sulfate to produce zinc sulfate and copper, and lead also displaces copper chloride to produce lead chloride and copper. These are examples of displacement reaction. What is double displacement? Let's take an experiment. In this experiment, we are having a test tube containing of barium chloride, and to this barium chloride we are going to add sodium sulfate. So if we are adding sodium sulfate, it will become barium sulfate and sodium chloride, and we'll see in the test tube we'll be having some curdy white precipitate. Why is this happening? This barium sulfate is formed, that shows a precipitate formation, and this reaction is called as double displacement. Why is it called double displacement? In this slide we saw iron is displacing copper, so only one is getting displaced, but in this reaction sodium is being displaced by barium and barium is also being displaced by sodium. Therefore it is like a exchange reaction, they both are exchanging between them. So if an exchange reaction takes place, that is known as double displacement reaction. Here sodium sulfate is exchanging its sulfate ion with barium to form barium sulfate, and barium chloride is exchanging its chloride ions with sodium sulfate to form sodium chloride, and this barium sulfate shows the formation of precipitates. Oxidation and reduction. What is oxidation? As the name says, oxidation. Therefore, there is something related to oxygen. So, oxidation is the addition of oxygen. The surface of copper, if we are taking a copper powder and heating it, it will become black in color. So, what is this reaction? So, copper is reacting with oxygen in the atmosphere. Therefore, it forms copper oxide, and copper oxide is black in color. Therefore, this reaction is an oxidation reaction because copper is being added. And what is reduction reaction? If oxygen is removed, that reaction is called as reduction reaction. If we are giving copper to copper oxide, if we are going to add hydrogen, we'll get this reaction back. Therefore, this reaction is getting formed. These products are getting formed again because of the addition of hydrogen. Because hydrogen combines with oxygen to produce water, which means oxygen is being removed from the product. Therefore, this is known as reduction reaction. If we are adding oxygen, that is called as oxidation. And if we are removing oxygen, that is called as reduction. So we are going to see one reaction where oxidation and reduction take place, and that reaction is called as redox reaction. In this reaction, if we see CuO plus H2 gives Cu plus H2O. Therefore, in the reactant side, oxygen is being removed. Therefore, it is a reduction reaction, and in the product side, oxygen is being added. Therefore, it is an oxidation reaction. How we are saying what is getting reduced and what is being oxidized? Here, from copper, we are removing oxygen. Therefore, copper is being reduced, and from to hydrogen, we are adding oxygen. Therefore, hydrogen is being oxidized. In higher classes, we'll discuss with respect to their valence rate. Some other example are ZnO on reacting with copper produces Zn plus O2. Here zinc is getting reduced. Why is it getting reduced? Oxygen is removed. Therefore zinc is getting reduced and copper is being oxidized because oxygen is getting added. And in this reaction manganese is getting reduced and because oxygen is being removed and hydrogen is getting oxidized. And for chlorine nothing is happening. So, oxidation in our everyday life. We know corrosion. What happens in corrosion? If we are keeping something iron product in water or something, it will get a brown layer on top of them, and that is called as rust. Why does this happen? This happens due to the reaction of oxygen in the atmosphere with that metal. Therefore, this is an example of oxidation reaction. Therefore, corrosion is also oxidation. To reduce these corrosion and all, we used to paint all the iron products so that they don't react with oxygen in the atmosphere. And what is randicity? Have you ever tasted or smelled the fat or oil from the food materials that is left for a long time? When fats and oil are oxidized, they form rancid and their smell and taste changes. Usually substance which prevent oxidation, if they are left for the longer time, are added to the food, it will become like this. So this is also an example of oxidation. And from the chips we get, earlier they used to add nitrogen to prevent oxidation to take place. So let's practice a few questions. In this question, they are asking which is getting oxidized and which is getting reduced. Therefore, Na plus O2 produces 2NaO. First, let's check the balance. Na is 4 in the reactant side and in the product side we have 4. Therefore, sodium is balanced and oxygen 2, and in the product side we have 2. Therefore, oxygen is also balanced. Therefore, this is a balanced reaction. And now, if we are seeing in the reactant side, sodium does not contain any oxygen, but in the product side, sodium is getting converted into its oxide form. Therefore, oxygen is adding. Therefore, this explains this is an oxidation reaction. And in the next reaction, CuO plus H2 produces Cu plus H2O. So in this reaction, what is happening? First, let's check the balance. Cu in the reactant side, it is one atom, and in the product side also we have one atom. Therefore, that is balanced. In the reactant side, oxygen has one atom. In the product side, also oxygen has one atom. Therefore, that is also balanced. In the reactant side, we have two hydrogen atom. In the product side, also we have two hydrogen atom. Therefore, this is a balanced chemical equation. So, if we are talking about oxidation and reduction, in the reactant side, copper has an oxygen atom, but in the product side, copper does not have an oxygen atom, which means oxygen is being removed. Therefore, this is an example of reduction. And to hydrogen in the reactant side, it does not contain any oxygen, but in the product side, it contains an oxygen. Therefore, oxygen is being added. This is an oxidation reaction. Therefore, oxidation and reduction is taking place. This is called as redox. Reduction oxidation reaction. What is the next question? A shiny brown colored element on heating in air becomes black in color. Name the element X and the black colored compound form. We have discussed this reaction in this slide. Please take your time and think, and then uh, resume the video and check the answer. So, shiny brown colored element on reacting with air produces black color product. Therefore, Cu on reacting with O2 produces CuO. Cupric oxide, therefore this is 2 cupric oxide for balancing, and this will also have become 2, and this is the complete balanced equation for the question. So this is brown in color, this becomes black in color, and this reaction is given in the textbook. Uh, in this question, this is the last example. In this, we'll see whether it is a combination reaction. In combination reaction, two reactants should combine to give one product. Here we are getting two products. Therefore, this is not combination reaction. And in double displacement, there should be some kind of exchanging taking place. Here, no exchange is taking place. Only one is getting changed. Therefore, this is not a double displacement. And in decomposition, one reactant should decompose to produce many smaller products. Therefore, this is not decomposition reaction. The final option is displacement. Is it getting displaced? Yes. Here, iron is being displaced by aluminium to produce aluminium oxide and iron. Therefore, this is a displacement reaction. Hope you enjoyed the video. Thank you and stay tuned.